Okay, welcome everyone and thank you for joining us today for Advancements in Rodent Surgical Monitoring, sponsored by Indus Instruments. My name is Andy and I will be your host for today's event. Before introducing our guest speakers, I would like to quickly review the webinar controls for everyone participating. There are two windows that will allow you to access important functions for the webinar. The first is the sidebar menu, and the second is the control panel. You can open or hide the control panel by clicking the arrow icon at the top of the sidebar menu. When open, the control panel is displayed and contains two sections, audio and questions. Note that voice over IP settings can be accessed by clicking on settings. Also, you can switch between voice over IP or teleconference listing modes if needed. Secondly, feel free to submit questions to myself and our guest speakers through the questions window. Now, I include this slide for any attendees that might be experiencing technical difficulties with their audio settings. So let's just take a moment to allow them to read these directions just in case people are not connected. Okay, now before I introduce our guest speakers and review what we will discuss today, I'd like to describe Insight Scientific's involvement in today's event and get some feedback from our audience. Insight Scientific is a new online educational environment designed for life science researchers. Our goal is to aid in the sharing and distribution of scientific information regarding innovative technologies, protocols, research tools, and laboratory services. This will be the first of many web events hosted this year, so we encourage everyone to register on our website so we can keep you informed of upcoming events. So what we're going to do is we're going to get some input from our audience now. You should see a poll appear on your screen now, so please just take the time to give us some basic feedback and then we'll get started. So we've almost got everybody chimed in here. We've got about 85% committed. I'm just going to give one short moment for our last members to participate. Okay, thank you very much, everyone. So our first speaker today is Graham Sattler. I've had the pleasure of knowing Graham for a few years now, and I can say he is very passionate about his work. He's a true advocate of rodent surgical monitoring, an application specialist, and product manager for all Indus Instruments biomedical solutions. Today, Graham will describe how Indus Instruments views rodent surgical monitoring and how they have designed the Mouse Monitor S to answer the needs of the research community. Next, we will hear from Dr. Corey Reynolds. Dr. Reynolds is the director of the Mouse Phenotyping Core Lab at Baylor College of Medicine. He has extensive experience and knowledge in the area of mirroring in vivo research models, and he is both an IACUC and animal care expert. Today, Dr. Reynolds will share examples of surgical monitoring from the core lab perspective and touch on both NIH and IACUC considerations. Third, we have Dr. Mary Lindsay. Dr. Lindsay is the director of the Jackson Center for Heart Research at the University of Mississippi Medical Center and is also a professor in the Department of Physiology and Biophysics. She's an expert in mirroring models of myocardial infarction and is currently focused on inflammatory and fibrotic mechanisms in pathogenesis of left ventricular remodeling. So now I'm going to hand things over to Graham and we'll get started. So Graham, we should have you online now.
You do. I just struggled a little bit with the unmute. Thanks for the introduction, Andy. I was going to start out by doing a quick overview of all the capabilities of the product and set ourselves up to go move on to Dr. Reynolds. So first I want to start out with what surgical monitoring can do for you in your lab, a couple of the capabilities of the Mouse Monitor S, and then talk about some critical surgical monitoring signals that are really informative during surgery to help you make kind of in-the-moment decisions about whether or not to proceed. And then touch briefly on whether or not surgical monitoring is difficult, or does it have to be difficult. So what can surgical monitoring do for you in your lab? Most of the people that we've placed the Mouse Monitor S with have initially bought the product as a way to acquire ECG signals or to heat the animal and monitor temperature. But what we hear back surprisingly most often from these labs is not that doesn't end up being their favorite feature of the product. What they say is that by having all of these ECG and respiration and numeric data available to them, they can ensure more consistent procedures and more consistent surgeries because they're able to notice kind of nuances in what's going on with the animal during the procedure. So that leads to increased survival rates with their experiments, and they're saying that the quality of the animals that are getting enrolled into their studies end up being significantly higher because they're saying, okay, I've got a good confidence that the entire surgery went over without a hitch, that I didn't notice any abnormalities during the surgery. And then the long-term survival rate coming out of surgery and going into the study group ends up being significantly higher. And lastly, it's a tool to kind of pursue the whole idea of continuous improvement and training new people coming into the lab. Because when you're trying to learn new surgery techniques, it's very, very overwhelming to try to keep track of the ECG, the heart rate, the respiration, the core temperature, while at the same time paying attention to all the challenging nuances that is microsurgery on mice and rats. And so by putting all the information in one place and making it easier for an overburdened researcher who's just getting into the surgery practice to kind of gather and make decisions on all this information in one place, you're able to really improve the surgical training both of very experienced and less experienced surgeons. And then all that put together leads to more consistent outcomes and more consistent data sets. What are the essentials of surgical monitoring? Well, in the development process, we spoke with a lot of researchers, and a lot of people said, well, you need to have heart rate, you need to have respiration rate, you need to measure core temperature, and we were really trying to figure out a way to put all of this in a one piece of visual display so that you could kind of look at one place, see everything all in one place, and make a decision based on that. So the capabilities of the Mouse Monitor, if you look on the right hand of the screen, there's a screenshot. There's the gridded area on the left is a waveform capture area where you're able to display ECG waveforms, any 6 leads, lead 1, lead 2, lead 3, AVL, AVF, and AVR, respiration signals, and if you have the blood oxygenation module, also blood oxygenation plethysmograms. On the right area, you'll see a couple numeric panels, and you're able to calculate heart rate off of any of the ECG leads. You're also able to calculate and display respiration rate, core temperature, pad temperature, and also R-to-R intervals and other, more esoteric values. The display is not limited to only 4 waveforms on the left or 4 numeric panels on the right. Both of them are configurable from anywhere from one waveform to 8 waveforms, and also 1 numeric panel to 8 numeric panels to kind of suit however you would prefer to have the display done. Pardon me. What are the critical surgical monitoring signals? So during surgery, it's an anesthetized technique, so you need to monitor heart rate and blood oxygenation and core temperature and pad temperature. And by basically being able to use the pad to heat the animal properly and monitor core temperature and monitor heart rate, you're able to, between all these signals, ensure that you're applying the appropriate amount of anesthesia and that the animal is in good health, and make decisions on those pieces of information as you proceed through the surgery. And finally, I'd like to touch on how surgical monitoring doesn't have to be difficult. I think most people are familiar with the challenges that come from trying to integrate multiple pieces of equipment, whether there be a heart rate calculation device on ECG or via blood oxygenation, and then there be a respiration detection device, and then a heating device, and then a core temperature measurement device. And one of the things that we saw in labs is, aside from the challenges and the inconveniences of hooking all of these disparate systems up into a larger, wholly working system, that it becomes difficult to control these devices, and it becomes difficult to understand the data that these devices are giving you. And so one of the focuses with the mouse monitor was to kind of take all this integration hassle, take all this operations hassle, take all of these inconveniences out, and kind of give preclinical researchers the same level of convenience that doctors and clinicians are used to having in the emergency room, in the operating theater. And so we developed a product that looks a lot more like a human patient monitor than in previous preclinical surgical monitoring systems. So even though the product is called the Mouse Monitor S, if you look at the picture down here at the bottom, you'll notice that there are some electrodes. There's a set of electrodes here in the middle. That's for mice. There's a set of electrodes here on the outside. That's for rats. And set of electrodes here for mice and set of electrodes here for rats. There's also a set of electrodes here on the front of the device that allow you to do external ECG electrodes. So you can do any sort of, sorry about that, so you can do many different types of electrode placement techniques for side entry surgeries. There's also a multiplexer available inside so that the orientation of the animal can be done in many different ways. The entire device is designed to have the surgeries performed directly on top of them with long-lasting surgical stainless electrodes and a surgical stainless operating platform on top. The controls on the tablet are all intuitive touch screens, and we've worked really hard in the past couple of months to improve the factory presets that come out of the box so that as soon as you open up the product and connect everything together, that it's ready to capture data with the right types of filters and the right types of settings, and that everything is as straightforward as possible. The last thing I'd like to note is that the mouse monitor, one of its key strengths and design features, is that all signals are acquired non-invasively, be it ECG, respiration, heart rate, core temperature. So the animal is not going to have any additional stress placed upon it over and above your surgery, so that's really a key feature for allowing you to collect data without adding to the stress and trauma of the animal. So I want to go over real quickly a couple of things that I just mentioned, and go ahead before I hand it off to the next presenter. And that's comprehensive monitoring is really a key to increasing the consistency of your surgeries, increasing the consistency of your interventions, and giving you the kind of consistent outcomes that we all want to have better science. And that, coupled with the other results of higher survival rate, really leads to animals coming into your study group that have much better outcomes and much more consistency of data sets, which is great for everything that we're working on. And lastly, I want to touch on the fact that the Mouse Monitor S is the only product that does, in preclinical research, that incorporates all of these disparate features into one device and makes it so that you don't have to go out and buy and set up a whole bunch of devices to get your basic surgical setup complete. Now I'm going to hand it off to Andy again for a set of questions and move on to the next presenter. Thank you very much.
Thank you, Graham. So we're just going to grab another poll from our audience here. So again, you should all now see our next poll. So again, we'll thank you in advance for taking the time to submit your feedback. We've almost had everybody respond. I'll just give everybody a few more seconds. and then we'll invite Dr. Corey Reynolds to take the stage. Okay, thank you again, everybody. Okay, and we'll pass things over to Corey now. And sorry, Corey, I've had you on mute there for a second. Corey, you're with us now?
Yes, I'm with you.
Perfect. All right. So you'll just have to accept your screen.
I didn't receive a...
Yep. I think we've got you now, Corey.
Okay, good. All right, so we're ready to go?
Yes, you're all set.
Sounds good. All right, again, my name is Corey Reynolds, and I'm the director of the Mouse Phenotyping Core here at Baylor College of Medicine. I want to start out by giving you an overview of what my core is and how we utilize the Mouse Monitor S. So the Mouse Phenotyping Core is a comprehensive facility. We offer expertise in the areas of imaging, metabolic assays, cardiovascular assays, respiratory assays, neuromuscular assessment, as well as various surgical services including transverse aortic banding, myocardial infarctions, telemetry device implantations, and cecal ligations. We are a fee-for-service core. However, we can accept animals, including rats and mice, from outside of facilities post-veterinary approval. We can run long-term studies and provide data analysis as well, and my contact information is listed below if you have any questions about our core. So in running a phenotyping facility or core facility in general, there are many different obstacles that we face. One being working with various species, another working with different clients and PIs. Clients can include anyone from graduate students all the way up to the level of the president of the university. We offer many different procedures, and when you work with many different clients and PIs, you often have to change the procedure according to their needs. And this also leads to various protocols designs. One thing that we found is that working with this Mouse Monitor S is that it kind of makes a lot of these procedures and protocols a lot easier for ourselves as well as the people that we work with. If any of you all work in animal facilities, I'm sure you're very familiar with ICUC facilities, so you probably should know about the Guide for the Care and Use of Laboratory Animals. Some things that are very important as far as these committees go is providing artificial heating to the animal during surgical procedures, as well as the monitoring of baseline vital signs, including the heart rate, core body temperature, and blood oxygenation levels. So in running my core facility, some of the things that I have to be able to do, because we do provide surgical services on pretty much an everyday basis, is we have to have the ability to monitor the core body temperature of the mouse, as well as having the ability to easily adjust the temperature. A difference in the Mouse Monitor S and other conventional ways of warming the animal, such as a heating pad or a water circulation pad, is that the Mouse Monitor S allows you to pick a specific temperature that you would like the bed to be set at. And to me, this is very important because sometimes you have to increase the temperature if your mouse or rat is more susceptible to being cold, or you can lower it according to the body temperature that you're monitoring on the screen. We also have the ability, or need the ability, to monitor the ECG rhythms as well as the heart rate. And we have the flexibility to do this for different size species with the Mouse Monitor S, as Graham pointed out earlier, because this board is set up to monitor both rats and mice. In situations where you are doing a survival surgery and you need the animal to be anesthetized for a long period of time, it is very imperative by the ICUC that you are able to monitor blood oxygenation levels. You can do this with the mouse monitor through an added module, and it's really easy to use. You just clip a little, actually just like a little clip onto the foot of the animal, and it is able to tell you the blood oxygenation levels on the same screen that you're noticing the heart rate, core body temperature, and pad temperature as well. And the last thing is that it provides a means of compact, comprehensive surgical monitoring, because it's essentially the size of a small board, and then all of your data is being output onto a pad. And those are the only two things that you have to have for this setup. This is an example of a screenshot that you would see on the pad while you're monitoring your animal during your procedure. You see that you are receiving data from ECG leads 1, 2, and 3, as well as the heart rate, respiration, core body temperature, and the pad temperature. It allows you to have easy screenshots because basically you just screenshot this to record it, and it allows for easy recordings. I really enjoy working with the mouse monitor. We actually have 2 of them in my facility because it allows a method to cleanly detect ECGs as opposed to telemetry or various other means that you may be familiar with, as well as it has an analog output making system integration quite seamless when working with other pieces of equipment. So advantages of working with the Mouse Monitor S concerning monitoring and recording is that it allows constant monitoring of the animal's vitals during surgery. These vitals are being documented on the monitoring system, and all of these things equal to a very happy eye-cut committee, as well as a much quicker protocol approval for you. This is an example of some data that was produced here in my facility for a mouse model that was involving tamoxifen being included in the feed of the mice. And you can see that actually in ECG leads 1, 2, and 3, that there are some very serious arrhythmias going on here. And once we went through and diagnosed it, we found that it's a sinus rhythm with bigeminal PVCs. But this just goes to show you that the Mouse Monitor S is providing a quite high-resolution means of ECG detection, and it enables easy morphology recognition and arrhythmia detection. And we do this on a daily basis. It's quite easy to use. Generally, you keep an animal down for 8 to 10 minutes, and you can get the data that you need. As I said before, the Mouse Monitor S has analog output, which makes system integration seamless. This is an example here of a Vivo ultrasound that we use here in my facility, and we've been able to integrate the Mouse Monitor S with this piece of equipment and pretty much coordinate or correlate the ECG signals detected with the Mouse Monitor S with those that we detect on the ultrasound for the heart functional data analysis as well. And that's all I have, so thank you, Andy.
Thanks, Corey. So again, we're just going to take our final poll here, and then we're going to invite Dr. Mary Lindsay to join us. Okay, so I'm going to pass things over to Mary now. We've just got a few more people sending in poll results. So Mary, I have you online now. Can you Are you with us?
Yes, I can hear you.
Perfect. Okay, we can hear you, and I'm going to pass controls over to you now as well. And finally, we'll close down this poll. Thank you, everybody, for your input. So, Mary, you can share your screen whenever you're ready.
Can you see my screen?
Not yet. There should be a small prompt on your screen that says share screen. There we are. And if you'd like to go ahead and go into presentation mode, we'll see your slides. That's excellent. Okay, it's all yours.
Okay, I'm trying to minimize the webinar part, but I think as long as you guys don't see that part, I'm okay. Good morning, everyone. It's my pleasure to talk with you today about some of the research that we have going on in our center. Along with me, I have Dr. Andrei Chomsky, who is the director of our core facility for our mouse animal use for our heart center. Our lab, our center, is interested in myocardial infarction. In our case, we use predominantly a mouse model of left coronary artery occlusion, where we occlude the artery and then look at the inflammatory and the extracellular matrix fibrotic responses to that model. And so after MI, the cardiac remodeling process involves a continuum of inflammatory and wound healing scenarios where leukocytes infiltrate and then fibroblasts get activated to form a collagen scar. And so the slide here just demonstrates the time progression in the cells that are involved with cardiac remodeling. Our lab has historically been interested in matrix metalloproteinases and the roles of MMPs as enzymes to break down extracellular matrix components after MI. One of our early papers that was published in the American Journal of Physiology, Heart and Circulatory Physiology, was this one here on MMP9 gene deletion. We showed that if you delete the MMP9 gene, it surprisingly has an effect on angiogenesis, and actually the deletion stimulates angiogenesis after MI. And so this got us interested in tracking down some of the substrates for MMP9 that were not necessarily involved with ECM. We've also shown that MMP9 deletion attenuates myocardial fibrosis and improves diastolic function in aging mice. Looking at mice of 4 different age groups, we've documented that MMP9 deletion makes cardiac aging look better. Ann Chow was a graduate student in my lab who's now at the University of Washington in Seattle, who began this research, and more recently Dr. Chomsky's been following up on what the role of aging has in our mice. In addition to MMP9, we've also evaluated the role of MMP7 in left ventricle remodeling post-MI. In this case, MMP7 was shown to have an effect on attenuated remodeling post-MI, but it wasn't necessarily a direct rupture phenotype. Instead, it was a conduction phenotype where EKGs came in very important to show that the MMP7 knockout mice had better electrical properties after the MI. We also used a proteomic approach to identify some novel substrates of MMP7 that were operational in the in vivo setting. And we published this paper here showing that fibronectin and canastin C were examples of 2 of the in vivo substrates. MMP28 is the most recently identified MMP in the family, and we published last year in Circ Research that deletion of MMP28 actually exacerbates, it doesn't attenuate LV remodeling, but rather it makes things worse. And so the MMP28 knockout mice are susceptible to rupture post-MI. And we've shown here that that phenotype was due to macrophage activation differences where MMP28 regulated the M2 activation process. And so those are just some examples of the different kinds of studies that we have going on in our lab. And we just have it summarized here, is that the effect of MMP9 deletion on aging mice in the post-MI setting. In addition, one of our pre-faculty fellows, Dr. Christy DeLeon Pinel, has an American Heart Grant to look at effects of MMP9 in the setting of pre-existing P. gingivalis infection. And so in the setting of periodontal disease, what role that has on the MI response. We're also interested in the role of MMP-derived peptides. And so when extracellular matrix gets cleaved by MMPs and generates fragments, what signaling roles do those fragments have in the post-MI setting? And then we also have selective MMP inhibitors that we're evaluating to look at roles of specific MMPs in post-MI setting. And so this slide here just shows an example of one of the mouse monitor screen captures that we made from one of our animals. And this is in a pre-MI setting, so before the LAD ligation. We typically look at lead 2, but we also, it allows you to acquire multiple leads. And then respiratory rate is one thing that's very important for us in surgery to make sure that the animals are being oxygenated properly. And so this is a pre-MI EKG, and then this is the exact same mouse taken after MI to show nice ST segment elevation. And so very similar to what you would see in humans, are the mice in the permanently occluded model develop ST segment elevation within minutes of the MI. And so this monitor is a very nice way for us to document proof of MI. When you're tying the coronary artery of a mouse, it's very, very small. And sometimes it's a little bit of a guess as to where you're tying off. And so having the EKG to show, yes, you got it, or no, you didn't, is really helpful for us. Our surgeries typically take about 15 minutes, and so it's not necessarily a prolonged anesthetic period, but having the mouse warm throughout that period is definitely beneficial. And so Dr. Chomsky, I'm going to turn the phone over to him, and he's going to tell us a little bit about, in particular, what he finds useful in our lab for using the monitor.
Thank you, Dr. Lindsay. Hello, everybody. We had the systems for almost a year now, and I can tell that pretty much everybody was very happy with it. I'm still as happy. I think most of all is our LF facilities administration is happy with our monitoring systems. I just put some bullet points over here which we particularly like about the system. The first one is reliable and accurate ECG recording. That's pretty much means that when you just put the electrodes, you get the readings right away. You don't have any hassle of adjusting or anything. And obviously, the multiple lead choice is also very beneficial. I know that some of guys in our lab use, as Dr. Lindsay said, one lead, lead number 2. I prefer to use 3. I don't usually go over more than 3 leads just because it sometimes gets overcrowded, but it's a very good option anyway. So you can also use to acquire the ECG. You can use either external or internal electrodes. So that basically means that you can either poke the mouse with the electrodes and record it like this, or if you don't want to induce any more stress to the mouse, like post-MI, for example, you can just use the external electrodes, which are built into the actual surgery pad. So the surgery pad has a heating system, which is awesome. I like it the most. That helps our mice to, to maintain the temperature, and we know that that the temperature is not one of the causes for post-MI deaths that we could possibly had in the early period before these systems. So the size of the pad is also very comfortable. I mean, the height and the width and the depth is very, very comfortable for doing surgery, especially when you put your hands up. It gives you like a nice grip and a nice support. You also have an external electrode for acquiring the temperature, which is also very useful. What I like the most, I think, about the system is the size. The system we had before was occupying pretty much the whole desk and a little shelf on top of it. So now it's a really tiny system. You have only a pad and portable tablets, which you can just carry on anywhere you want. And it's very easy to transfer data to your computer for your analysis or to take any images, and the one we used in this presentation. And I think this is it. Thank you very much.
Thank you, Andre.
Thank you, Andre. And that's that concludes our comments.
Excellent. Thank you very much, Dr. Lindsay and Andre. I'm going to take back controls of our presentation here. And so right now what we have scheduled is a Q&A session. We've actually had some great questions come through our webinar interface already. So what I'm going to do is I'm going to invite our guests to come back on the audio, and I'm going to share some of these questions with the group, and then kind of we'll have an open discussion. So Corey, I should have you online. Mary, you still online? And Graham?
Yes, I'm here.
Perfect. So
I'm here as well.
Great. So let me just pull some of these questions out. Bear with me. And again, this is the appropriate time for all of our attendees. Feel free to just send in any questions that you have now. I can then post them back to our audience. So we had one person kind of curious what other type of animals this could be used for. I mean, Graham, this is branded a mouse monitor, but you already mentioned during this presentation it accommodates rats. Are there any other research models that this could be used for?
Yeah, we've actually seen the Mouse Monitor S used on bats at Dr. Lindsay's previous location when she was at UTHSC San Antonio at the Bar Shop Institute, and also in naked mole rats. One of our collaborators, Dr. Reddy, is also working with current researchers at the Bar Shop Institute on doing research on naked mole rats. We've seen it used on hamsters and on gerbils and on guinea pigs. So it turns out that the rough spacing of the electrodes and the length of them for rats and the same set for mice ends up getting a very wide variety of small animal and murine models.
Excellent. Okay. Thank you very much. Our next question actually talks about system integration. This has come from an attendee who is using a pressure volume loop system. Now, Graham, I would expect that this would just call on, like in general, can be answered in general, where the analog outputs would be used from the system to then interface, other devices along with the mouse monitor signals through one data acquisition system. Can you kind of just explain that for the audience?
Sure. Yeah, the Mouse Monitor S has a module that allows for analog output, and all of the channels that it allows up to 8 channels on this module, which is pretty challenging for a data integration perspective, so most people use a subset of the channels that we have available. But each channel is configurable as to what signal that you want to send out on them, and also what filters you wish to apply. The filters you apply to the exported analog signals can be different than the signals that you have, the filters that you have applied to the display unit. So that allows you to, put all of the waveforms on the tablet viewed in such a way where it makes sense for you to do your analysis, but you may want to send unfiltered signals or signals filtered differently out to your data acquisition system. So we've seen it integrated with both Molar and with Sisense pressure volume loop systems with no issues at all. And it provides a very good preparation and stability platform for beginning that fairly extended type of experiment.
Excellent. Thank you. So let's, the questions are flooding in here. This is excellent. And just I'll take this moment as I'm moving through. We probably won't be able to get to all questions during this live session, but all will be answered and distributed to all attendees. So as far as actually this is a really good question. Someone's asking about multiple system integration. So in the event someone has a lab where they would like multiple platforms, how would you suggest kind of arranging that? Would it be that each mouse monitor is kind of a standalone, or can maybe this calls on the system integration again, or analog output feature? Could a series of mouse monitors then be collected in a larger data acquisition system with perhaps input limits around, say, 32 or 64, because those are common in some industry labs?
Well, we don't really have a formal a formal large-scale deployment plan worked out where you can have multiple base stations powered off of a fewer number of tablets. But actually, Mary Lindsay's and Andre's lab is a good example of how you can fit a number of these different systems in a small space. Andre, would you like to talk about that a little bit?
Sure. In our lab, in our surgery room, we have four stations which are provided with with 4 different monitor systems. So far, we never had a problem or trouble. We don't have a log system. It just is, it's one tablet per station. And if multiple people desire to use it, they just whenever you do a surgery or you record ECG, there is an option you put. You give your study name and your own name. So it's pretty much it just stores in a different folders, and you can just grab it from there. Yeah, I hope this answers the question. There is no problem with different users.
Yeah, I'll just add a little bit to that. We find it very easy just to have standalone systems for each of our surgery stations. The cost and the ease makes it worth it. So we don't try to have one setup to record all the EKGs from all the systems.
Yeah, because I believe if I remember correctly, Mary, you said that there's times when you actually have 4 different surgeries and 4 different surgeons all going on at the same time.
That's correct.
Cool.
Excellent. Very good.
Well, hopefully. Oh, sorry. Continue, Andy.
Okay. I'm going to jump in with a couple more questions. We have one specific question about ECG filtering within the device. So, I mean, I would imagine that if anyone really wants to see this happen, the best thing to do is arrange an on-screen demonstration, which I'm sure, Graham, you'd be happy to do. But if you could describe briefly what's the process and what options are available through the mouse monitor directly for ECG filtering.
Okay. Well, there are 3 different filters that can be applied to ECG and also to respiration. There's a high-pass filter, and there's a low-pass filter, and then there's a notch filter. And I'll go briefly over what each one does. A high-pass filter, it passes high-frequency signals. So basically, this is your opportunity to eliminate kind of the overall baseline drift of your signal. And so instead of having the ECG kind of riding on a gentle rolling wave, you can apply a high-pass filter that allows you to stabilize the baseline and make it easier to kind of understand what your signal looks like in a raw form. There's a low-pass filter, which, again, passes low frequencies. And what that allows you to do is allows you to filter out a whole bunch of high-frequency noise. So if you have some sort of other equipment in your lab or a radio signal or any sort of RF interference, you can apply a low-pass filter, and then you can eliminate that. So a good example of this would be in the standard configuration of the mouse monitor S. The ECG ships with a high-pass filter of 2 hertz. So that means that anything lower than 2 hertz is going to get ignored, essentially, or filtered out before it is displayed. And on the low-pass filter, we have a 1,000 hertz filter. So basically, if you were to have any gigahertz, megahertz RF frequency noise, you're able to filter that out and ignore it so that you don't have a whole bunch of crazy gobbledygook messing up with your respiration or ECG signals. A notch filter is really useful for when you've got power line interference or some sort of cyclical, maybe you're getting some sort of bleed through from the transformers on your fluorescent lights. So sometimes there's some filters there that are useful for kind of cleaning up some of these signals. We also have a couple different ways to change the grounding schemes to figure out how to integrate best with other pieces of equipment and other devices, because every lab is different and there can be different types of grounding scenarios, different types of noise situations. So we've implemented a robust filtering mechanism as well as a multimodal grounding solution for trying to tackle these different types of problems.
Okay, that's excellent. And actually, on this, on this note, is it also fair to assume that the analog output of that signal can be untouched, so to speak? So it would be passed on to an external data acquisition, and then data management at that point can be handled downstream?
That's correct. We've implemented actually a feature that allows you to either export the signal with no filtering or to apply a set of filtering that is anything that you wish. It's independent of the filtering that goes on the display. So if you want to apply aggressive filters on your display and no filters on your output, or light filters on your analog output, then either of those options are possibilities.
That's a great feature. Okay, thanks for clarifying that. I think, yeah, I'm looking for our final question here. Again, thank you to all of our attendees that have sent excellent questions through, and we will get to all of them. I'm just searching here. There was one that really caught my attention. That's right. So let's spend a little bit of time just reviewing the pulse ox side of the system. Maybe if you could address 2 things. There was one question about what is the ideal placement of the sensor on the mouse, I guess we'll use as an example. And then also just in general, if there's any concerns or how the system has system features that have been built in to ensure optimal signal clarity, because you're pulling so many signals from one device. How is Indus really focused in on making sure that these signals are as clean and true as possible?
Okay, well, someone stop me if I'm getting too nerdy. I'm a little bit involved in the engineering process, so sometimes I can get carried away. Our background is 22 years of instrumentation design, so we're keenly aware of the effects that disparate systems and disparate measurement mechanisms can have on interfering with each other. And so taking care to implement a very good isolation, filtering, and ground isolation scheme throughout all of the different devices was very important in the design phase. And it's one of the key elements that enables us to kind of integrate all of these different measurement modalities without them interfering with each other, without them causing any sort of signal interference. So that's kind of the approach that we took for that. And as pertaining to the pulse oximeter measurement, we have a clip that clips onto the thigh, as well as clips that are clip onto the foot and lower leg for both mice and rats. And we're in continual development on those clips and improving them to reduce their size and increase their ease of use. So the only thing that I will note is that with any clip on a dark-haired mouse, normal protocol is to shave or nair the leg to remove the dark-colored hair, because that's an impediment to the light frequencies that are used to measure blood oxygenation, and that's just a matter of the way that the technology works. So one of the advantages of using a clip placement on the foot is that you don't have to shave the hair, but one of the disadvantages is that placement on the foot is keenly sensitive to the internal temperature of the animal. That's not necessarily a problem with our system because of the robust heating system that's integrated into the product, but that can be a challenge of trying to use other foot-based pulse oximeter sensors because you're unable to use the sensor and at the same time maintain sufficient core temperature.
Excellent.
So hopefully that addressed the issue.
I think that was great. Well, perfect. We've come to that point in this this online event that we're going to close things down as we've blocked off about an hour for our presentation. I want to officially thank everybody for attending and also thank all of our excellent presenters today. Dr. Corey Reynolds, Dr. Mary Lindsay, Andre, and Graham, you've all done a great job. Thank you very much. Again, this presentation will be available on Inside Scientific, and I believe Indus will be posting it on their website as well. We will distribute all the slides and the question content to all attendees and those that registered. So also if you know of colleagues or you know, your research peers that had registered but weren't able to attend, let them know that they will be receiving this information before the end of the week. So just before we close off, I'd like to also mention to the group that Inside Scientific has 3 web series that will be starting in February. We're going to start with a focus on pressure volume loops to measure cardiac function. This session will include presentations from scientists, one that is already going to be reviewing physiology and kind of the basic background of pressure volume loops is Dr. Daniel Burkhoff. Following that, we will have a series on implantable biotelemetry. And then finally, you will see an event starting focused on non-invasive blood pressure monitoring. So again, Inside Scientific will hold all the details about these specific events, and we invite people to pre-register so we can keep you in tune of you know, the additional speakers and sponsors that take part. So thank you very much, everybody, and have a great day. See you again next time.